Hello everyone. Welcome to the next lecture on the PY question series. Today I will explain you how you can solve the questions related to the differentiability. Myself Dr. Harish. You can follow my YouTube channel where you can find the playlist of the CSIR UGC net and you can see the various lectures related to the topic wise and the subject wise is available in this playlist. All these lectures are available with the help of the shortcut tricks. Now, what we have discussed so far, we have covered the PY questions on the limits. We have discussed the PY question of the continuity and uniform continuity, all these lectures in our last lecture. Now, this is the today's objective of this PY question series. But make sure that before watching this lecture and to understand this lecture deeply, you must watch about my previous 3 lectures. I use the same shortcut tricks and the concept in this lecture. You can find all these lecture in my YouTube channel, Dr. Harish. Moreover, I hope this is my last lecture for all of you because the simple I do a lot of the efforts for all of you. You are watching the videos, but you are not supporting me. So I try to understand that, but there is no issue. But don't worry, if this is my last lecture, then still I will explain you till the last of this question in this video with the full confidence and the energy level. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now, first of all, before I start with the PY question series, let me quickly give you the one simple idea. Try to understand the question very deeply. Question की बारीकी को समझिए हमेशा examination में. Once you can understand the question in a very deeper manner, you will get your answer in a very less time. अगर आपने क्वेश्चन की बारीकी को समझ लिया तो आपको आंसर जो है वो 10 और 15 सेकंड में मिल जाएगा. बट द मोस्ट इंपॉर्टेंट थिंग इज यू हैव टू अंडरस्टैंड व्हाट द एग्जैक्टली क्वेश्चन आस्क यू. इसलिए हमेशा ही जब भी आप पढ़िए, पहली बात तो आप अपने पे कॉन्फिडेंस रखिए. CSR net is one of the easiest exam that I feel fine, but the only thing is you have to understand the questions and the subject deeper. सबसे मुश्किल एग्जाम है. अगर आप ऐसा सोचते हैं CSR के बारे में तो ये गलत है. अगर आपने सब्जेक्ट की नॉलेज है, अगर आप क्वेश्चन को अच्छे से समझ पा रहे हो, देन यू कैन क्रैक दिस एग्जामिनेशन विद इन अ फर्स्ट और सेकंड अटेम्प्ट. दैट्स अ वेरी सिंपल अटेम्प्ट. फाइन. चलिए अब स्टार्ट करते हैं इस क्वेश्चन की सीरीज को. So let's start with the question answer. First of all, you try to understand the question deeper. Fine. You can devote a 5, 10, 15 second more to read the statement. Then you will get a 5, 10 or 15 second answers in a lesser time. So look at that. I is the subset of the R. So it's a R. Try to write always in the graphically if it is possible for you. This is my R. I is my 1 and 2. So that means this is the singleton 1, singleton 2. I can write this is my 1, this is my 2. Fine. Then you have to define the phi, which is the distance between the x and I, where I, that is the infimum. You can think about infimum is just like say minimum, all those collection of the y in the I. That means what is the I? I is 1 and 2. So that means your target is to find the distance between these two quantities. Fine. Now can you draw the graph of this? X minus 1, x minus 1. Fine. Y minus x minus 2, x minus 2. Can you find this point of intersection? That's very easy. What is the graph of this line? This line is x minus 1. Can you find the graph of this line? This line is my minus x plus 2 because it's a decreasing. So both are equal at this point. You will get 2x is equal to 3. That means x is my 3 over 2. So this point is 3 over 2. Fine. Now you understand this question. Now this is the graph of this function. Look at the answer. Phi is discontinuous somewhere on the R. This is my R. Is the function is discontinuous? No, because mod is always a continuous function. Option discard. Phi is continuous on R, correct, but not differentiable only at x is equal to 1. So clearly say from the graph, function is not differentiable at 1, at 3 by 2 and at the 2. So there are the 3 non-differentiable points. So this option is cancelled. This option is cancelled. D is my right answer of this problem. You can see that. Just try to understand this statement very easily. I is the subset of the R. Now you can see this is my R, minus infinity to plus infinity. Now I is my closed interval 0, comma 1. Again, you can see this is my y belongs to the I. Any number in between the interval is the minimum of them. So clearly say, if you choose any number in between them, what is the minimum of this? That's a 0. Fine, because if you take any of the x, say any number, say 0.5, so once x will be the 0.5, because x belongs to the R, it will be the 0, and for other x it will be the non-zero, so the infimum will be 0 because it's the modulus value. So what is the graph of this? And at the end point it is x minus 0 and it is x minus 1, so the graph will be this man. Fine. So this is the graph of minus x. This is the graph of x minus 1. How many discontinuity points? That's one is a 0 and one is it a differentiable? The function is not differentiable at x is equal to 0 and x is equal to 1. The function is discontinuous, wrong. Function is continuous, fine, but not differentiable at x is equal to 0. At x is equal to 0, but not continuously differentiable, but the function is differentiable at x is equal to 0. Function is continuous on R but not continuously exactly at 0 and 1. Function is differentiable at all R. C is my right answer of this problem. Look at this next question. Take the closed interval 0, comma 1. This is again the R, because you can see again it's the infimum of this. Take the closed interval of 0, comma 1 and open interval 1 by 3, that's a 0.33. This is my 0.33 and this is my 0.66. Now k is my collection of all those elements of the 0, 1 minus of this, so that is my, this portion is my k, this portion is my k. Define for all x. Now instead of, in this case it is instead of the R, this is my 0, 1. Fine. Then you can define all those y in the k. So where is the k? K at this shaded portion is my k, this shaded portion is my k. Now your target is to find all those x from the 0 and 1. So what is the graph of this? You can see this is 1, this is 0, this is the open interval 2, comma 3. So whenever x lies in the k, the graph will be 0. Whenever x lies in this k, the graph is 0. And what about the other? Whenever it's a k, this one, and it is decreasing. Can you find this point of intersection? This graph will be my x minus 1 over 3. This is my minus x plus 2 over 3. So both are equal. That means 2x is equal to 1. X will be half. So that means you have the 3 point of the differentiation, 3 points at which the function is not differentiable. So look at that. The function is not continuous, but you can see the function is continuous everywhere. The function is not differentiable at 1 by 2, fine. The function is not differentiable at 1 over 3 and 2 over 3, fine. Function is differentiable at all point is the wrong answer. So second and third is my correct answer of this problem. I hope you can like and comment on my video to support it. Let f is a twice differentiable function such that f double dash x is pi greater than 0. Fine, that is the meaning of convex function. Fine. Otherwise, can you think about any of the function which is whose second derivative is greater than 0? X square or x square minus 1 or x square plus 1 and so on. Fine. Then f of x is equal to 0 has exactly two solutions in the R. That's wrong. If I consider this function, f of x is x square plus 1. What is the root of this? Roots are plus minus iota, which is not belongs to the R. F of x is 0. F of x is 0 and f dash is 0. What do you think about this? F of 0 is 0, f of 0, f dash 0 is 0. That means f0 is my double root. Fine. So if f is my double root, that means this is my x square. Fine. Now this will satisfy this property. Then f of x has a positive solution. What is the solution of this problem? This solution is my 0 comma 0, but you can see there is no positive solution. F of 0 is 0, f dash is my greater than 0. Now I will think about the another example. F dash is my 0, f dash is greater than 0 or f dash is less than 0. So if I choose x square plus 1, what is my f dash? Is my 2x. Then f of 0 is 0. So you can't consider this. If I choose this part, then it will be my plus 1. So then f of 0 is my 0, satisfied. F dash of 0 is my 1, which is greater than 0. Fine. Then it has no positive solution. You can see, can you find the solution? The roots are 0 and minus 1. It has no positive solution. But this is the one counter example. We can't correct the option. Look at this one. F dash is my 0. If I choose x square minus x, then what is my f dash x? 2x minus 1. Clearly say f dash 0 is my less than 0. What is the roots of this equation? 0 and 1. And it has no positive solution. You have a one positive solution which satisfied. Now all these other options are cancelled out. Right option is C is my correct answer. F is my twice differentiable function, so that f of 0 is 0, f of 1 is equal to 0, f dash of 0 is equal to 0. Again, what does it means? That means 0 is my double root. Fine. And this equation also say that 1 is the simple root. Fine. So can you define the function? 0 is my double root, so it's a x square. 1 is my, now since it is not given that what is the degree of the polynomial, so this condition will satisfy. Now we can define its derivatives. X cube minus, so now you can see second derivative. The first derivative is 3x square minus 2x. Second derivative is 6x minus 2 is a 0 function. F double dash 0 is a 0. Wrong. F double dash 0 is 0 for some x belongs to this. Yes, if I choose x is my 1 over 3, then clearly say f double dash of x is my 0, because he said for some. But this is one example. We can't correct this example based on this. F double dash never vanish. That's wrong. If I take this, then it will be 0. So this option is cancelled. Only left option is C is my right. F is a real function. F is a function R to R such that f of 0 is 0 and the derivative of the function is less than equal to 5. Which of the following statement hold? Very simple. You can just try to understand it because it's the upper bound. I can firstly take df over dx is equal to x and then discard the option. You can integrate them. F is equal to 5x plus constant. Now because f of 0 is my 0, so that will give you c is equal to 0. That means f of x is my 5x. Our target is to find the value of the f1. F1 is equal to 5. Fine. Now look at the first option is the open interval. Not satisfied. This is satisfied, but this is the one counter example. We can't say that. 5 does not belong to this. 5 does not belong to this. So all the other options are cancelled out. Correct option is B is my right answer. And you can see within the 10 to 15 seconds, you can solve this problem. Simple man. I hope you can like and comment on this video. F is a twice differentiable function, so that f of ax plus 1 minus a into y is less than equal to a times fx plus 1 minus a times fy. Do you know which condition is? That is means f is my convex function. Fine. So any example of the convex function? F of x is my x square, because we know that x square is my convex function. Now look at that. First derivative. First derivative is 2x. Is it always greater than 0? No. Yes, it is always greater than 0. But you can see, because f is my convex function, so what is the definition of the convex function? Second derivative must be greater than 0. If I take this example, you can see the second derivative is my 2, which is less than 0 cross. This is my cross. Fine. Now, because of the convex function, second derivative must be greater than equal to 0 is the only right answer of this problem. Now, f is a function which are defined to be this. F is a bounded variation or not. Okay. How you can check about the bounded variation? If I give you the tips, x raised to power m sine x raised to power 1 over n, or you can see x raised to power m cos 1 over x raised to power n, such that m is my greater than 0, n is my greater than 0. Then f of x is bounded variation if m, or let me clear it, if m is greater than of n. Fine. Now look at that. M is my 2, n is my 1. 2 is greater than 1. Yes, f is my bounded variation. Clear? F dash. Can you find the derivative of this? It's a 2x cos 1 over x minus minus plus minus, it's a sine 1 over x. Find x square and 1 over x cancel out. Now clearly say this is my 1, this is my 1. It is not greater than, it is not bounded variation. Fine. One more shortcut tips. So, firstly, I can solve it and then we'll tell you the shortcut tips again. Then your target is to find the derivative. What is the f dash of this? Is a 2x cos 1 over x plus sine 1 over x. So clearly say this will be less than of 2x plus 1. Since on this interval x will be less than of the 2 plus 1, that is less than equal to 3. So fourth is the correct option. Third is the wrong answer. So A and D are my correct answer of this problem. Now, one more shortcut tips for you. If your function is of this form, again, x raised to power m cos 1 over x raised to power n, or it can be written in the sine form, x raised to power n sine 1 over x raised to power n, then f is said to be the continuous if m is greater than 0. F is said to be differentiable if m is my strictly greater than n. Fine. So in this case, they are talking about the bounded variation. If somebody will ask you if f is a continuous or not, because m 2 is my greater than 0, yes, it's a continuous. Is it a differentiable? Yes, it's a differentiable because 2 is my greater than 1. So differentiable is there, continuous is also correct. F is defined to be x into sine x into sine 1 over x. G is defined as x into fx, that is x square sine 1 over x. Then is there bounded variation? No, because 1 is not greater than 1. So f is not bounded variation. Is G is the bounded variation? Yes, because 2 is my greater than 1. G is not bounded variation is the wrong answer. So you can see within the 10 to 15 seconds, you can get your answer in a very simple manner. This is the bounded variation. If you want to find more lecture on the bounded variation, you must watch about my these previous lecture. Bounded variation. If you want to find the Riemann integrations, improper integral, uniform convergence, that is the sequence and series of the function. Power series, all you can find at my YouTube channel. Okay, now look at this another one. F is a two dimension, theta is my unique real number such that minus pi is less than of theta is less than equal to pi. That is called as the fundamental period. Fine, is the fundamental period of this polar form. Then the theta will be differentiable, continuous, bounded, not bounded. What is that? Theta is tan inverse y over x in the polar form. Now you can clearly say that what is the domain of the tan inverse? Pi by 2. So that means it is my bounded. Fine. It lies between minus pi to pi. So that is a bounded function. Neither bounded, cancel. Now we have to check about the continuity or differentiability. So how you can check about the continuity? Because it's a two-dimensional random variable, I can choose the path y is equal to mx. So this is my tan inverse m. Now it depends upon the m. That means the limit is not unique. If the limit is not unique, that means the function is not continuous. If the function is not continuous, that means the function is not differentiable. So function is not differentiable, function is continuous, but we get not continuous. Function is not continuous. C is the answer of this problem. Now you can see it's a December 2023. I can solve the same question in the same manner as I explained previously. F is a differentiable function such that f and f dash has no common zero, only in the closed interval 0 comma 1. You can choose any numbers. Let's say this. What is the zeros of this? That is the root. Root is my plus minus 1. What is the derivative of this function? Is that 2x. What is the root of the derivative? 0. There is no common between them. It satisfied my this requirement. F never vanish in the 0 comma 1. That's wrong, because f of 1 is 0 and 1 is also belongs to this. F has at most finitely many zeros. How many zeros of the f? How many zeros of the f? That is a plus minus 1. That is my finite. But this is the one counter example. We can't correct this option until we can discard the others. F has infinitely many zeros, but we get a finite zeros. F of half is my 0. What is the f of half? It is my 1 over 4 minus 1, which is non-zero. So this option is also cancelled. Only left behind is B is my right answer. And you can see this is the recent year paper. How many seconds you are needed to solve the problem. Always remember your target is to discard the option, not try to find the exact answer. Try to discard the option. हमेशा कोशिश करिए एग्जाम में काउंटर एग्जाम्पल दीजिए जिससे सारे ऑप्शन डिस्कार्ड करो, जो करेक्ट होगा वो ऑटोमेटिकली बच जाएगा आपके लिए. फाइन. हमेशा ही डिस्कार्ड के बारे में सोचना है आपको. F is a polynomial, real polynomial of degree 4 such that minus 1 is equal to 0, f of 0 is equal to 0, f of 1 is equal to 1. What does it means? That means 0 and minus 1 is my root of the function. Fine. And 1 is not the root of the function. Fine. So can you define the function? Also, it is also given that f dash of 1 is equal to 0. That means 0 is my double root. So can you define the polynomial? 0 is my double root. Minus 1 is also the root. Now it has a degree 3. What about the other one? It can be any other number. X plus a. A can be 0. A can be 1. But A can be 1. But A can never be minus 1. Because f of 1 is my non-zero. Fine. Now if you open this bracket, it is my x4. I can simply choose A is my 0. Fine. Because it has a double root. So it may, because it satisfied this polynomial, I can choose x cube, x plus 1. Fine. And we will see which options are discarded. Fine. So it will be x raised to power 4 plus x cube. You may choose any number apart from the minus 1. You can choose a as a 2. Now look at that. Third derivative. Firstly, we can find the third derivative. 4x cube, 3x square. Second derivative. 12x square, 6x. Third derivative, 24x plus 6. Clearly say my this function will satisfy my given requirement. Now third derivative is my this case. There exists any a which lies between the minus 1 to 1 so that the third derivative is greater than. There exists. We are not talking about the all. So clearly say if I choose a is my 0, which lies between -1 to 1. So clearly say the third derivative is my greater than 6. That option is correct. Third derivative is greater than 3 for all. That's wrong, because if I choose any number, say -1 over 8, fine, or -1 over 12, then it will be 4. Now I can change the other number. I can choose, say, -1 over, I can choose any number in -1 over 3. Fine, it lies between the -1 to +1. Then what is the value of the third derivative at this point? It is a -8 plus 6, which is not greater than 3. So this option is cancelled. F of 3 0 lies between 0 and 2. What is the f of 3 0? 6. 6 is not lies between this part. Third derivative is greater than equal to 3. So you can see if I take x is 0, the answer is 6. 6 is my greater than 3. A and D are my correct answer of this problem. Now, the function, okay. Firstly, I will give you the shortcut tips related to the modulus value. Remember that mod of x is not differentiable. Fine. Mod of x square is differentiable. Why? Because mod of x square is always x square. Now, if you look at this function is a naught plus a1 of mod x square. Mod of x square is always x square. Fine. X cube is always my, is either a plus x cube or minus x cube. Okay. Mod of x cube is my not, sorry, mod of x cube is my differentiable function always. Fine. Now look at the option. There is no value of the a naught is a differentiable. If I choose a1 is 0, a2 is 0, a3 is 0, then what is my fx? Fx is my a naught. A naught I can consider as a 1. Clearly say this is my differentiable. So for no value is a cancel. For any values of this ai's, if I choose a0 is 0, a1 is my 1, a0 is my 0, a2 and a3 are my 0, then f of x is my mod x, which is my not differentiable. So this option is also cancelled. Only if a1 is 0. If a1 is 0, then your function will be a naught plus a2 x square plus a3 x cube, mod x cube. X square is my differentiable, x cube is my differentiable at x is equal to 0, then it is my differentiable. Yes, it is satisfied. A cube is 0 is not necessary. So the right answer of this problem is only C is my correct answer. Which of the following point is not differentiable? Okay, that's a very simple. Firstly, I will give the shortcut tips. If you have the function, let's say mod of fx, then this function is not differentiable at the points where fx is my 0. Fine. The function is not differentiable at the point where fx is 0. Now look at that. That means this function is not differentiable when cos x is 0 and sine of 2 minus x is equal to 0. So that means cos x 0 means x will be my 2n plus 1 pi by 2 and 2 minus x will be my n pi, or x will be my 2 minus n pi, where n is my integer. Fine. So 2n plus 1 pi by 2, fine. This is wrong, because if you take n is equal to 2, then the answer will be pi and the cos pi is not 0. N pi is wrong. 2 minus n pi, this is also correct because n is my integer. I can say this is my m pi, where m is my integer. So yes, A and C are my correct answer of this problem. Again, you can see this is the function. So first of all, this part, this is the mod x. So this is not differentiable at x is equal to 0. This function is not differentiable at x is equal to minus of 10. Fine. But this is the cube. This is the cube. So this function is always differentiable. It's a cube is always differentiable. So there is, so minus 10 is cancelled out. 0, fine. Sine of this, so that means x minus 3. This function is not differentiable at x is equal to 3. Fine. Or moreover, you can also check about this function. This is x minus 3. You can type, you can derivative them. It's a cos x minus 3 and the derivative of, what is the derivative of the mod x? You know what is the derivative of mod x is? X over mod x. So that means x minus 3 over x minus 3. Now if you take the limit, x approaches 3, cos of 3, cos of 0. Cos of 0 will be my 1. Its number is my minus 1 or plus 1. That means limit is not unique. That means the function is not differentiable. Look at this one, whether the 5 is a differentiable or not. We can again differentiate this. It's a minus of sine x minus 5 into x minus 5 over x minus 5. Take the limit as x approaches 5. So this is the sine 0. Sine 0 is always 0 into any number which lies between minus 1 to 1. This is a 0. That's a unique number. Fine. Because the limit is unique. So therefore this function is my always differentiable. So the only function which is not differentiable is 0 and plus 3. So 5 is a differentiable function. Right answer is B and D are my correct answer. That's why I'm asking you, you can watch my PY question series of the limits and continuity. That's the most important lecture before watching this today's differentiability. Okay, your function f of x will be e raised to power mod x into e raised to power x square plus x square minus 1. So clearly say this function is not differentiable at plus minus 1. This function is not differentiable at x is equal to 0. So you have how many points at which the function is not differentiable? 0, 1, minus 1. Function is not differentiable at 1 and minus 1. Function is differentiable at x is equal to 2. Function is not differentiable at x is equal to 0. Function is not differentiable exactly at 3 points of the R. All are my correct answer of this problem. Okay, look at this another one. A function fx is given to me. There is a no continuous function. No continuous function of x comma gx will be 0. That means x square minus g cube x is equal to 0. Can you find the value of the g? G will be x raised to power 2 over 3. Now look at the option. There is no continuous function. You can see this is my continuous function. Fine. So this option is cancelled out. There is exactly one continuous real value function defined on the interval containing 0. So 0 is contained in this. That is exactly one correct option. Exactly one differentiable function. Can you find the differentiation? It's a 2 over 3 x raised to power 1 over 3. There is exactly one differentiation in the interval containing 0. You can see this function is not differentiable when 0 belongs to the domain. So this function is not differentiable at 0. There is two distinct real value differentiable function which containing 0. That's also wrong answer. Only left behind is my B is the correct answer of this problem. And you can see that a very simple approach I have explained you in this video as well as in the other videos. Now what is given to you, f is the mapping from Rn to R, which is defined by x1 xn is equal to a1 x1 plus a_n xn. That is a question related to the function of several variables. Fine, but you can solve it easily. I can choose n is my 1. Fine, so your mapping will be R to R, which is defined as AX. Fine, where A is my non-zero constant, non-zero vector. Fine. Let df0 is the derivative of this function at the point 0. So what is the df? What is the df0? Derivative at the point 0, which is a, and a is my non-zero, derivative is my non-zero. D of f is a linear map. You can see derivative is a constant function. Every constant function is my linear map. D of f0 is my a. If you multiply this by a will be any number. If you multiply this by a, it will be a square. And because a is my vector, and now I consider as a real number, so this is number is my a square, which is the correct option. D of f0, this is my D of f0. If I multiply this by a, it will be a square, and he said 0. But clearly say a is my non-zero, so this number is again my non-zero. D of f0, this is part is my a, this is my b, but n is my 1, so it is my only b, so that is my ab. That is my correct statement. So the right answers are a, b, and d are my correct answers. And you can see I have transformed the function of the several variable to this single variable, and you can get your answer again in a simple manner. Again, you can see it's a function of the several variable. Fine. I can again convert into the function of the real line. So that means f is a mapping from R to R such that df is my derivative of the f. F is my any differentiable function. I can choose, this is my differentiable function, dfx. What is the dfx is? Derivative of the function at the point x. What is the derivative of this is? 1. And at the point, firstly I can find the derivative. Derivative is my 1. Then derivative at the point x is also 1. Fine. Then which of the following is my correct? df0. Derivative at the point 0. What is the derivative at the point 0? Is again 1. So therefore df0 multiply by u. This is the derivative into u, that will be my u, and he said it is my 0 for all u in R. That's wrong. If I choose u is equal to 1, then it will be my non-zero. So first option is cancel. Second option dfx. Dfx is my this quantity. Fine. Now if I multiply this quantity by u again, this number is again my u, and which is again non-zero, but he said for all the u. If I choose u is my 1, which is my non-zero. This is my 0 again for all. This is again the cancel out, and the only right option is my this. How? F is a not constant function. This is my not a constant function. Derivative is my 1 1. So if you draw the graph, what is the derivative of the 1 graph? It's a constant function. Then it is a 1 1 for some x. So what is the sum x? If I choose any one x, say 1, so then it is a 1 1. Fine. So the rest of the option is my correct option. Make sure it is, if he said for all x, then it is not true. But if he said for some x, then it is true. Or you can think about, if you want another example, let's say any constant, non-constant function, say f of x square. What is the derivative is? 2x. What is the derivative at the point x? Is my 2x. Fine. If you draw the graph of the 2x, it will be my this. Now how you can check about the differential 1 1? You can draw the horizontal line. It cut at the 1 point. Yes, it is my 1 1 function. If you want to find, you can also solve these questions with the help of the function of several variable. How you can solve them? You must watch about my these two lectures, and this is the differentiability and the continuity of the function of several variable. You must watch about my these 4 lecture so that you can learn again with the help of the shortcut tricks how you can solve. Again, you can see the function of the several variable. You can solve same question with the help of these methods. But if I want to solve this with the help of the differentiability on R, if I choose n is my 1, it is R to R defined by, what is that? This is the x cube. Fine. For all x in my R. Then which of the following statement is my correct? Can you find the derivative of this function? 3x square. Then df into 0. Differentiation into 0 is my 0. That's the correct option. Derivative of the function at the x is my 0 for all x. That is wrong. If I choose x is equal to 1, then clearly say derivative is my 3, which is non-zero. F is my 1, 1, x cube. If you draw the graph of the x cube, this is my x cube. Now how you can check about the 1, 1? You can draw the horizontal line. It cut only at the single point. Yes, it's a 1, 1. F has an inverse. F is my x cube. Fine. So what is the, how you can find the inverse? I can take it as a y. So F inverse of the x will be my x raised to power 1 over 3. And since x is a mapping from R to R, this is in my R. Yes, it has the inverse of this problem. So the right answers are A, C, D are my correct answers. Again, it's a function of the several variable, but again you can see I can convert into the one dimension variable. If I choose n is by 1, then your mapping will be R to R. This function will convert into n is 1, then it will be the summation only collection of all those x such that x square will be less than equal to 1. So what is the value of this? Minus 1 to plus 1. So that means it's a closed interval minus 1 to plus 1. It's a closed interval, but a is my strictly greater than 0, but I need a negative of the number. That's a wrong. A is my greater than 0, wrong. It's a 0, 1, but I need a minus 1, 0. Minus a plus a, I can choose any number, say a is equal to 1. For some a, if I choose a is equal to 1, then a is my right answer. You can see with the help of the very shortcut tricks, you can solve each question in a very simple manner. उम्मीद करता हूं आप थोड़ा सपोर्ट करेंगे इस वीडियो पे भी, लाइक और कमेंट करके शेयर करिए अपने दोस्तों के साथ. Now it's a partial derivative, direction derivative. If you look about this statement, what is given to you? F is again is a function of the several variable. Fine. Partial derivative, then the directional derivative, directional, and this. What is the shortcut tips for you? If partial derivative of the x and partial derivative of y exists and continues. Fine. If the partial derivative exists and continues for all x and y lies in the domain, then the function is, or you can say this implies f is my differentiation. F is differentiable at all the points of the domain. Fine. Second point, if f is differentiable, then it means f has directional derivative exist in all directions. Fine. If function is differentiable, then the directional derivative exists in all direction. But make sure converse need not be true. Similarly, for this case, converse is not true. Fine. So now you can see this function is bicontinuous. Every polynomial function is bicontinuous. Also, it's a polynomial, so it is existence. So its existence and continuous satisfied means it's a differentiable at all the points. It f has a derivative at all points. F does not has a directional derivative. Once the function is differentiation or differentiable, then the function has a direction derivative in all direction. It has a direction derivative only. Because of this only, this option is cancelled. A and B are my correct answer of this problem. Again, you can see if I choose n is my 1, what meaning of that? F is my mapping from R to R. This norm will convert it into the modulus fx minus fy is greater than equal to x minus y. Fine. Now f is on to, f is close, f of 0 is 0. Can you think about any of the function which satisfy this property? Clearly say x plus 1. Fine. X plus 1, y plus 1. 1 and 1 will be cancelled out. It's satisfied. But clearly say f of 0 is my non-zero. Fine. Now, how you can prove that it's a on to? Firstly, you can divide it both side by fx minus fy divided both sides by mod of x minus y. Find it's a greater than 1. Take the limit as x approaches y. So this part will be modulus of f dash is my greater than equal to 1. That means function is my unbounded. Fine. And it is monotonically increasing. F dash is my greater than 0, is a monotonically increasing, and the derivative will go to the infinity. It's the unbound. Fine. So what we have is a continuous, it's a unbounded, it's a increasing. Fine. So the only thing we have to prove is a onto. If we prove that it's a 1 1, then it is onto as well. Now you can see. Assume that I will check whether it's a 1 1 or not. Assume that fx is equal to fy. So this part will be 0, x minus y. Since modulus value can never be 0 or can never be less than 0, so that means x minus y is 0. Therefore, x is equal to y. Hence, f is my 1 1. Fine. F is 1 1. Also, f is continuous. Also, f is my unbounded, and f is my monotonically increasing function. This completely also suggested you that f is my onto. So f is my on. Fine. Now, once you prove that f is my onto, what will happen? What is the f of r? F of r is nothing but r, because f is onto. Now, this r is my open, this r is also closed. So that means f of r is a closed subset of this correct option. Open is my also correct option. A, C and B are my right answer of this problem. Now, f is a continuous function. F is a continuous function on this open interval. That means f is continuous at C also, because C lies in between them. Assume that f is differentiable at every point of the a comma b, but not at the C. F dash has the limit at C. F dash has limit at the point C, that is existence, say L, that must be unique and fine. Then f is differentiable or not. I can apply the definition of this. This is f dash x. How you can apply the f dash x? Fx minus f of any point, say f of c over, sorry, over x minus c, which is equal to L. Now it must be existence. That's a finite number. Fine. But if you look about the left hand side, if you substitute this number, what will happen? As f is my continuous, that means limit x approaches c of fx is my f of c. So this will be my 0 by 0 form. Then I can apply the L'Hopital rule. X approaches c, f dash x over 1, which is L. What does it mean? That means this f dash is my continuous. Fine. Or you can see if the differentiable function is my L, that means f is my differentiable at the point x is equal to c. Fine. F is my differentiable at the point c. F need not be differentiable, that's wrong. F is differentiable at the point c and the limit is equal to L. What is the L is? What is the L? You can see L is my f of c, but if you apply the L'Hopital rule, this is my f dash c, because f is differentiable, f dash is my continuous. Once this is my continuous, then this limit will be my f dash c. So this option is also cancelled. A and C are my right answer of this problem. F is my function, continuous function from which satisfied this property f of x into dx, which is 1 to t f of x into dx. Then which of the following are my necessary true? Can you think about any of the function? If I choose fx is 1, does it satisfy? Integration of 1 will be t, and this case is 1 minus t, which is not equal. Can you think about any function which satisfied this property? If I choose fx is 0, so clearly say 0 is equal to 0 satisfied. So option C will be discard by taking this. And you can see 0 is my continuous function. F of x is greater than 0. That's also a wrong option. Now, f is differentiable because every 0 function is differentiable, but based on this, we can't correct the a and b. Now you can, because we need a f, I need to remove the integration. So I can differentiate this with respect to x. How you can use the integration and differentiation? By using the Leibniz tool. So f of t into 1 minus 0. This is f of 1, f of upper limit into derivative of 1 minus f of lower limit into derivative of 1. You can also write the same quantity here. F of lower limit 0 into derivative of 0 is my 0. So this implies f of t is my minus f of t. That means f of t is my 0. So every 0, f is 0. 0 is my constant function, is a differentiable. 0 is my monotonic as well. A and B are my correct answer of this problem. Now, how many real roots? This kind of the question definitely asked in the examination. Whenever you are talking about the real roots, you always apply the discard rule of sign. Always. Fine. Discard rule of the sign. So first of all, if the function is my odd degree, if my function is my odd degree, then there exists at least one real root. Fine, at least one real root. Now look at that. What is the discard rule of sign? I have to apply the number of the positive and number of the negative roots. So what is the number of the positive roots? Fine, number of the positive real roots. We can check about the nature of this change of the sign. There is no change in the sign. Now you can see it's a plus and minus. There is one change in the sign. So it has one, at most one number of the positive roots. How many number of the negative roots? How you can find the number of negative roots? I can find the f of minus x firstly. It is minus x cube minus 3x minus 23. So clearly say there is no change in sign. So there is no negative roots. Now since it has a 3 roots because the cubic, one root is my positive, other two are my complex roots. And we all know complex roots always occur in the pair. So if one root is complex, second also complex. How many real roots? Real means positive or negative. So that means only one is the real root of this case. Also make sure that if you think about that, one negative rule occur and one complex root, that is not possible, because if alpha plus iota beta is the root, then alpha minus iota beta is also the root. So the complex roots always occur in the pair. So the right answer is B is my correct answer. Let P is a polynomial of real variable such that x raised to power n, a of n minus 1 plus up to a 1x minus 1. So I can choose the value of the n. If I choose the value of n is 1, it will be a0. But a0 is not given to you. That means I can never choose n is 1. If I choose n is 2, it's a a1. Then it's satisfied. So what is that? It is my x square plus a1 x. This is the term, and minus 1. Now P has no root in the open unit disk. Open unit disk, that is there is no x which belongs to the minus 1 2 plus 1 such that P of x is equal to 0. And given that P of minus 1 is equal to 0, what does it means? Minus 1 is the root of the equation. Now since this is my quadratic root, how many roots are there? Two roots. One root is my minus 1, other root I can assume alpha. Then sum of the root will be minus b over a. Product of the root will be c over a. That's a simple 8th class question. Now it becomes a 8th class question. From this equation, what you conclude? Alpha will be 1. So once alpha will be 1 from this equation, a1 will be 0. Once a1 will be 0, your polynomial is my x square minus 1. And clearly say the roots, there is no x in the open interval. So p of 1 satisfied. Infinity satisfied. P of 2 greater than 0 satisfied. P of 3 is equal to 0 is the wrong answer. Correct options are A, B and C are the right answer. Now again x cube, x raised to power 5 minus 5x plus 2. Clearly say this function has the odd degree. So at least one real root will be there. It has no real root. We can find the number of the positive roots. How many change in the sign? So there is a two changes in sign, positive to negative, negative to the positive. So the number of the positive roots are at most 2. Fine. If I calculate the minus of x, it will be minus x raised to power 5 plus x raised to power. Then how many number of the negative roots? Number of the how many change in sign is 1. Fine. All the roots are my real. That's wrong because the maximum number of the real roots from this and this. How many real roots occur? 3. So it means the remaining two roots. What is the remaining two roots? Are my complex number, and complex number always occur in the pair. So all the roots are real. That's a wrong answer. Exactly one real root. That's wrong because the number of the positive roots are my 2. So exactly real roots are my 3 is the right answer of this problem. The equation f of x is 11x plus 13x plus 17x minus 19x has one root, real root, exactly roots. How you can find the roots? First way, because it's not a polynomial, you can't check about the discard rule of sign. This is not applicable. This is applicable only for the polynomial. Which theorem come in your mind when you think about the roots? Intermediate mean value theorem. I can found that two numbers a and b so that their product will be 0. Fine. You can see what is the f of 0. 1, 1, 1 is greater than 0. What is the f of 1? 11, 13, 17 is again greater than 0. What is the f of minus 1? It is 1 over 11, 1 over 13, 1 over 17, 1 over 19. So clearly say this is also greater than 0. But you can see f of minus infinity. This will be the 0. This is the 0. This is the 0. This is the 0. And what is the f of infinity? It is my infinity. Fine. But how you can say about the number of the roots? Can you find any point whose where fx will be less than 0? How you can think about that where fx is less than 0? Uh, so you can see in all case it's a greater than 0. Now let's see check about the derivative. We can see about the bounded nature. So it's a 11x log of 11 plus 13x log of 13 plus 17x log of 17 minus 19x log of 19, and then f dash of 0 is a log 11 into 13 into 17 divided by 19, which is my greater than 0. That means no, it's a greater than 1 because it's a greater than of the 10. So log of 10 is my greater than 1. That means f dash is my increasing function. Once f dash is increasing, derivative once f is infinity, the value will be 0. It's an increasing function. So that means it's increasing. That means it can never decrease. So that means it has exactly one real root. Fine. So it has exactly two real roots cancel. Only one real root is my right answer of this problem. Because the function is increasing. You can see the function is increasing like this manner. Fine. And at the infinity, the value is infinity. Fine. and at the minus infinity is a 0. So definitely it will cross the x-axis at least exactly one time, then it will be increased. The polynomial of the odd degree with the real coefficient must have at least one real root, no real roots, only one roots. Either you can provide the example. This is my odd degree. Fine. Is there any real root? Yes. X is equal to 1 is my real root. It's a no real root. Fine. If I take the second example is x cube minus 1. Fine. How many real roots? How many roots are there? This, and the roots is my only one real roots. Only real roots, because it has a complex roots also. At least one root which is not real. At least one root which is not real. At least one root which is not real. That is wrong. If I choose this example, all the roots are my real, but it said at least one real root is my right answer of this problem. A, B, C are my distinct numbers, then the number of the real roots. I can choose any distinct number. A is equal to 1, B is equal to, C is equal to minus 1. What will be your fx? X cube plus x plus 1 cube, x minus 1 cube. Or I can take b is equal to minus 1. So it will be my minus 1, it is my plus 1. Fine. If I open this bracket, it's a 3x cube plus 1 and minus 1 cancel out. It's a 3x square. It's a minus 3x square plus 3x square cancel. It's a 3x plus 3x is my 6x. So 3x will be common. It's a x square plus 2. Then the number of the distinct real roots. Can you find the roots of this? The roots are my 0 and plus minus root 2 iota. You can see there is one real root occur. He said two real roots. Cancel, 3 cancel, depending upon the alphabet ABC cancel. One root is my right answer of this problem. Now you can see it's a December 2023. Again, you can solve it in a very simple manner. F is my cubic polynomial with real coefficient. You can choose any cubic polynomial. Fx has exactly one real root. This is the example which satisfies this property. And this root is simple. That means 1 is occurring only one time. This property is satisfied. Then, which of the following has the properties about the antiderivative? Can you find the antiderivative? That means the integration of this is a x4 by 4. I can choose 4x cube. So that once you integrate them, it will be x4 minus x. Then how many roots are there? You can see it's a x cube minus 1. How many real roots? Can you find the roots of this? Roots are my 0, roots are my 1, roots are omega, omega square. I got the two real roots. Then exactly 4 real roots. Exactly 1 real roots. At the most 2 real roots. At most 1 real root. This example also cancel. The left option is C is my right answer of this problem. You can see if you read the statement very carefully, you will get your answer in a very simple manner. Kindly support my videos by liking, sharing and comment. Kindly subscribe my YouTube channel as well. Okay, f is my continuous, differentiable and so on. How you can check about the continuity? X approaches 0 of fx. This is my 1, which is same as f0. That means function is continuous. So function is discontinuous, cancel. How you can check about the differentiability? I can found the derivative at the point x is equal to 0. Always use this definition, fx minus f0 over x minus 0. What is the value of the fx? Sin x over x. F0 is my 1. I can take the LCM also. Sin x over x minus 1 over x into x is x square. Can you take the limit? It's a 0 by 0 form. So I can apply the L'Hopital rule. This is my cos x minus 1 over 2x. Cos 0 is 1. Again is a 0 by 0 form. So I can apply the L'Hopital rule again. Limit x approaches 0 minus sin x over 2, which is my 0. Fine. So that means limit of x approaches 0, f dash is my 0. Also you can see at the point 0, what is the derivative of this? At the point 0 is 0. That means the function is my differentiable. Fine. The function is not differentiable cross. Now function is differentiable more than once. How you can check about the more than one? I can again apply the same definition. Fine. Now in that case, it will be my second derivative. It is first derivative. It's a first derivative. Fine. Now what is the value of this f dash x? I can see what is the f dash of x. It will be cos x over x minus sin x over x square and 0 otherwise. Fine. This is my x is non-zero and this is my 0. Now I can substitute this value again. In this case, we will see whether this limit exists or not. Limit x approaches 0, f dash x, this number is a cos x over x minus sin x over x. I can take the LCM, it's a x into x square. F dash 0 is my 0, divided by x is x cube. If you substitute 0, again it is a 0 by 0 form. I can apply the L'Hopital rule. It's a minus x sin x plus cos x minus cos x. X cube 3x square. This will be cancelled. 1x will be cancelled. Sin x over x when x approaches 0 is a 1, which is 1 over 3, which is not equal to the derivative values at the point 0. That means it is not differentiable. That means f double dash is not differentiable. More than 1 is cancelled. Only C is my right answer of this problem. Okay, this is a similar question. Clearly say f is my continuous. It's not a continuous. As I already defined that f is my not differentiable. Fine. So this is my differentiable function. Fine. This option cancel. This option correct. F is my bounded. I can start from this to quantity sin x over x, which is less than of 1 over x. Now this is my less than finite for all x in the R apart from the 0. Fine. Now we will check about the behavior at x is equal to 0. What is the limit of the function sin x over x? This will be my 1, 0 by 0 form. So cos x over 1, 0. That is my finite. So that means this function is less than finite for all x. That means, what does it mean? This is my bounded, but he said not bounded. So right option is only C is my correct answer. Okay, let f is my function which is x square of this. We have to check about the differentiability. Firstly, we will check about the continuity. What is the x approach is 0 minus? 0 minus is 0. What is the x approach is 0 positive? 0. F of 0 is my 0. That means function is continuous at x is equal to 0. Then we can check about the differentiability. Make sure if the function is not continuous at the point say 0, then the function is not differentiable at the point 0. Then we will check about the derivative. Limit x approaches 0, fx minus f0 over x. Substitute the value. So I can check about the firstly left limit. Fine. Left limit of the differentiability. What is the f dash is x square. F of 0 equality is at this point 0 over x. The answer will be 0. What is the right hand limit? If you consider the limit as 0 positive, fx minus f0 over x. What is the f dash? It's a 2x plus x square. F0 is a 0 divided by x. Clearly say it's a 0 by 0 form. If I apply the L'Hopital rule, it is my 2. Then clearly say these are not equal. That means f dash is not differentiable function. Now also we see at the point 0, f dash is not differentiable at x is equal to 0. So if f dash is not differentiable, what does it mean? F dash of 0 does not exist. Fine. So if f double dash does not exist, this option is correct. Second option, first option is cancel. F dash exists for each x which is non-zero. Yes, because this function is differentiable for all x in the R apart from the 0. So if function is differentiable, derivative exists for all x is a non-zero. F dash 0 does not exist. Yes, it does not exist. So right answers are B, C, D are my correct answer of this problem. Look at this next one. F is a differentiable function. Which of the following statement are necessarily true? If first option is, if derivative of this function is less than equal to r, which is less than 1, then it has at least one fixed point. Okay, they are talking about the fixed point. If f has a fixed point, then the derivative will be less than 1. That's a wrong statement. If you simply choose the function as a 3x, clearly say this is my 3x, and if you draw the graph of the y is equal to x, clearly say it has a fixed point. What is the fixed point is x is equal to 0, but what is the derivative? 3, which is not less than 1. Fine. Again, f has a unique fixed point. X is my unique fixed point. Derivative is my greater than equal to r, and it is less than 1. Derivative is my, what is the r? R is not given. So I can choose any other one. Say sin x. Clearly say it has a fixed point. 0 is my fixed point. This is my sin x. Fine. Then what is the derivative of this? Cos x. Then cos x is lies between -1 to +1. And you can see f dash is my greater than of -1, and that -1, is it less than 1? No. So that option is cancelled. Now look at the first option. Now I think that's the first option is correct. You remember what is the fixed point theorem? The first result is my by using the fixed point theorem. Fine. Last point is also my fixed point theorem, or somebody called as the contraction mapping theorem, or it is also called as the fixed point theorem. Either you call it as the fixed point theorem or the contraction mapping theorem. The right option is A and D are my right answer of this problem. Consider the function tan x on the set not equal to pi by 2 and so on, which has a fixed point. Can you draw the graph of the fixed point of the tan x? This is the graph of the fixed point. This is the value correspond to the pi by 2. This is the minus pi by 2. Then this is the value of the 3 pi by 2. Fine. And so on. Fine. Pi by 2, 3 pi by 2 and so on. If you draw the graph of the fixed point, how many fixed points you have obtained? 1, 0, 2, 3. Similarly, if you draw the graph at this point, then this line will be extended. How many fixed points you have obtained? It has infinitely many fixed points. Fine. So they have infinitely many fixed points is the right answer. Unique fixed point cancel, you can see graphically. No fixed point cancel. More than but finite is also cancel. C is my right answer of this problem. Okay, let P is a polynomial with the real coefficients. Then which of the following statement is my necessary true? P is my polynomial. It is not given that what is the degree. You may consider x minus 1. You may consider x square plus 1 and so on. There is no root of the derivative p dash between the two roots of the polynomial. Exactly one root. Okay. Let me know what come in your mind when you read this statement. Do you know any relation between the roots and the polynomial and the derivative? Which things come in your mind? Rolle's theorem. Fine. What is the Rolle's theorem says? If f is my continuous on the closed interval, f dash is my, sorry, f is my differentiable in the open interval such that f of a and f of b are same, then there exists at least one c in that open interval, say a comma b, such that p dash of c is equal to 0. What does it means? What is the meaning? How you can interpret this term? That means c is the root of p dash, and that's the question suggested you. So how many roots you are needed? Because polynomial, every polynomial is continuous, every polynomial is differentiable. You can easily make them. Let's say I can choose the polynomial as x square minus 1, and interval I can choose this part. Then clearly say f of b and f of a are same, then there exists at least one c, and that c will be my 0. Fine. So there is no root. Cancel. Exactly one root of the derivative between the any two roots. That's not the any two real roots. Between the any two consecutive roots. That option is cancelled. D is my right answer of this problem. Okay, look at this one. F is a function which satisfied my fx minus fy is less than equal to k times x minus y raised to power alpha, where alpha is my greater than 0. I can choose alpha is 1. If I choose alpha is 1, this number is 2. Now, if I divided both sides by x minus y, then mod of x minus y, then it will be less than of k. Take the limit as x approaches y. So this will be f dash of x will be less than equal to k. What does it means? F is my bounded and satisfied the Lipschitz continuous. Once f will be my Lipschitz continuous and bounded, then f will be my uniform continuous. So every f is my uniform continuous. If f is my uniform continuous, then f is my continuous as well. Fine. Now look at the third option. Every differentiable function f, every differentiable function is in f. That means if I choose say x, fine, this is the differentiable function, then according to the statement this f belongs to the f. Clearly say this is satisfied, fine. But you can see f is my r to r. Can you provide me the one example which is my not uniform continuous? Because the second option suggests every f is my uniform continuous. Can you provide me the one example which is not uniform continuous? X square. How you can think about that? You can watch my this uniform continuous lecture. Make sure student. Now you can see this is my differentiable, but it is not uniform continuous. So that option is cancelled. Every f is differentiable. You can see mod of x. If I choose f of x is my mod x, it satisfies this property, fine, but it is not differentiable. So the right options are A and B are the correct answer of this problem. Okay, again this is similar. Beta is my greater than 0. I can choose beta is my 1, or you can see the first option, beta is my 1, fine. So again same example, I can choose mod x. It satisfies this function, but it is my not differentiable, fine. F must be the polynomial. This function satisfied, clearly say this is my not polynomial. Beta is greater than 0. I can choose beta is 1. Again, you can see this function is if you divide by mod of x minus 1. So that means f is my Lipschitz continuous. Once this is my Lipschitz continuous, that means f is my uniform continuous. Fine. Now, second option, third option. If I choose beta is my greater than 1. If I choose beta is greater than 1, I can choose beta is my 2. Then again I can divide by x minus y modulus. This is my x minus y. Then it will be my x minus y. Take the limit as x approaches y. The left hand side will be my f dash of x. Right hand side will be x approaches y is a 0. Once the derivative, because mod is can never be 0, that means f dash x is 0. That means f will be my constant function. So C, B and C are my right answer of this problem. F is my mapping from A to R such that F is my uniform continuous. That the same shortcut tips as I told you. Then it means F of A is my bounded. F of A is my bounded. That means A is my bounded. But they are talking about F is bounded. So by using this result, F is my bounded. F is my necessary constant function. Can you think about any of the function which is my uniform continuous? You can see mod of x. I need a 0 to 1. I can say x minus 1. Clearly say this is a uniform continuous. It's not a constant function. It is not a differentiable in this. It is not differentiable at 1. It is not differentiable in this. So the right answer is A is my right answer of this problem. You can watch about my this lecture uniform continuity. You can see all these questions. I have already explained you the shortcut tricks in this lecture and how you can compute the limit. You can find these three lectures very useful for you related to the limit, continuity and differentiability. Again you can see what is the meaning of supremum of f dash x is less than, that means f is my ellipsis continuous. If f is my ellipsis continuous, that means f is my uniform continuous. The last option is the correct option. If f is the uniform continuous, then f map bounded set sequence to the bounded sequence, f map Cauchy sequence to the Cauchy sequence, f map convergent sequence to the convergent sequence. All are my right answer of this problem. You must watch about my previous lectures so that you can learn the tricks, so that once you go to the examination you can crack the examination in a very simple manner. मैं बार बार कह रहा हूँ बच्चों, examination is a very very simple. You just try to understand your concept and problem solving approach. सिर्फ आपको कंसंट्रेट करना है how you tackle the statement. आंसर आता है नहीं आता, that's not a big thing. अगर आपने स्टेटमेंट को अच्छे से समझ लिया आपको आंसर अपने आप ही आ जाएगा, अगर आपने मेरी सारी वीडियोस देख रखी है. If you watch my all videos, start from the first to the last, available in this playlist, and you can tackle the question in a very simple manner and get your answer within the 10 to 15-second time. Anyhow, let's the next question. F is a real value differentiable function. G is given to be f dash plus iota times f. F dash is my derivative. A and B are the two consecutive zeros of the AF. That means f of A, f of B is my zero. Which of the following statement are my necessary true? G of A is my greater than 0. What does it mean? What is the G of A? F dash of A plus iota times f of A is my greater than 0. But f of A is my already 0. That means f dash of A is my greater than 0. That means f is my increasing function. Now let's draw the graph. These are my zeros. These are my zero. F is my increasing. So that means if the graph will start from this, definitely it will be either of this form, fine, because it's a continuous and differentiable, or it can be of this form. But now you can see that f is my increasing, so definitely the graph at the point A, that means the function will be goes to this side. That means f dash is my greater than 0. But once the function is increasing, it is not an unbounded, because the function is increasing continuously differentiable. Definitely it will be decreasing, so that the graph will be converges to the point B. F of B is 0. So that means it will goes up and then down. Fine. Now look at that. G crosses the real line from the upper half and then to the lower half. That's the right option. G of A is 0. G crosses the real line from the lower half and then upper half. That is not possible. This is possible only if f is your decreasing function. Now look at the third option. What is the third option is f g of A, g of B is my non-zero. G of A, g of B is my non-zero. What is the g of a? Because f of a is my 0, so that is my f dash of a, and this is f dash of b is my non-zero. So that means either f dash into f dash of b is greater than 0, or other option will be f dash of b is my less than 0. Then ga and gb have the same sign. What is the f dash a, f dash b? That's the g of a. Now if both are my greater than 0, that means either f dash and f dash b have the same sign. Fine. Now again you can see the graphically, this is my root, this is my 0. If f dash a is my greater than 0, that's a positive, this is also positive, that means f is my increasing at the point a, f is increasing at the point b, which is not possible. Why? Because if the graph is increasing at the point a, increasing at the point b, then f of b will never be 0, but f of b is my 0 is given to you. That means both are my positive, not possible. Fine. That means both have the same sign, not possible. Or you can think about, if both are my negative, then what will happen? That means both are my decreasing at the point A, at the point B. Again, because f of A and f of B are 0, it must be converts to, that means the unbounded, but that is not possible. So that means same sign is not possible. So if this is not possible, that means this happens, and this happen only if one of them is positive, other is negative. You can see if this is increasing, at this point it's a decreasing, then only it will convert to the 0. So the right answer of this problem is A and D are my right answer, because you all knows that you can see, you can also see that what is the f dash of a? F dash of a is nothing but my g of a. Fine. Similarly, f dash of b is my g of b. So both f dash are of opposite sign, means g of a and g of b are my opposite sign. You can see, if you read the statement and understand the problem in a simple manner, you can get your answer definitely. अगर आपने अच्छे से समझ लिया क्वेश्चन को, आंसर गारंटी है वो आएगा ही आएगा आपका एग्जाम में, चाहे वो टॉपिक आता है चाहे नहीं आता। स्टेटमेंट को अच्छे से समझिए अब बिल्कुल ध्यान से। ओके, लेट f of x is tan inverse, there exists a polynomial f dash. Firstly you can find the f dash, which is 1 plus x square. Fine. There exists, can you find a polynomial? If I choose the polynomial is 1 plus x square, no, if I choose the polynomial is 1 plus x square only, then clearly say the product will be 1. Satisfied. Now derivative. Derivative is 0 for all the even numbers. Sequence is unbounded for all n. Firstly, we can see about the first derivative. This is the first derivative. F dash of 0 is 1, which is non-zero, because he said for all. Fine. Now, how you can find the nth derivative? So now, how you can find the nth derivative of the function? You can see 1 plus x square, f dash of x is my 0. Then I can apply this successive differentiation. Fine. What is the successive differentiation is? nc0. This is my n plus 1 derivative of x into what is the successive derivative of the function? How you can define it? This will be my 1 plus x square plus nc1 f of nth derivative into derivative of this plus nc2 f of n minus 1 into derivative of, and the rest of them will be 0. Fine. Then your target is to find the point at 0. So at x is equal to 0, this value will be 0 because of this quantity. Then the nc0 is my 1, f of n plus 1 of 0, this is my 1, nc2 n into n minus 1 over 2, and this 2 will be cancelled out. This is n minus 1 of 0. Fine. So that means I can found the n plus 1th derivative is my minus n minus 1 of n minus 1 of 0. Then it is for all even. If I choose n is 1, then it's the second derivative. If n is 1, it's my 0. What is that? If I choose n is 3, then if n is 3, then it will be my minus 3 into 2. This is my f of 2, and f of 2 I obtained as a 0. This is again 0. Similarly, f of 6, if you take 5, then it is 4, again 0. So all the even derivatives are my 0. Now, what about the odd derivatives? So if you take n is my odd derivative, if I take n is my 2, so it is my 3. It will be n is my 2 minus 2 into 1. This is my f1 0. What is the first derivative is 1. This is minus 2 into 1. What is the f5? Because f4 will be 0. 5 means f4, n will be 4. Minus 4 into 3, f3. So what is the f3 is? 4, 3, 4 into 3 into 2 into 1 into 1. That is minus n factorial into 1. Fine. N is my, sorry, n minus 1 factorial. It's a 5, it's a 3. So similarly, if you take it as a n, it will be n minus 1 factorial, and clearly say this is my unbounded. Why? You can see it goes to the infinity, and yes, it is my unbounded. So A, B, C are my right answer of this problem. Okay, look at this another one. Consider the following statements. Which of the following are my true? E of cos is not equal to E of 2022 sine of t. Oh, that's a very simple. Assume that when they are equal, because you can see if I check whether they are equal or not, that means tan of t is my 1 over 2025, which is a finite number. Fine. And definitely there exists a t which belongs to the 0 and pi, which will satisfy this property. That means if they are same, then e raised to power cos of t is same as e raised to power sine of t. But he said not equal to. S1 will be cancelled out. Only S1 cancel, this option cancel. Now it is S2 and S2. So I need to check only S2 because S3 is my true in both the cases. Now you can see for each x there exists such that x belongs to the log of e 1 plus x e raised to power t. First of all, let me know what comes in your mind when you think about this term. Any result which comes in this manner, there exists. That's a Rolle's theorem, Lagrange mean value theorem. So I can firstly simplify this because I need a value of the t. Can you find the value of t from this expression? It's e raised to power x. Fine. I can also written as e raised to power x minus 1 over x, which is e raised to power t. Now you can see this is just look like say fb minus fa over g of b minus g of a, which is f dash of say c and g dash of c. Let me know what is the name of this. That's a Cauchy mean value theorem. Fine. That's a Cauchy mean value theorem. So the only condition is f and g are continuous and differentiable on this interval. Fine. So let's see what is the value of the fx. If you compare them, I can choose fx is e raised to power x. What is the value of the gx? You can choose an as a x. What is the value of the a? You can choose an a f of 1. So that means a I can choose an as a 0. Also the lower limit is 0. B I can choose an as a x. Now clearly say f is my continuous, f is my differentiable. This is continuous, this is differentiable. And you can see this term is my this part. Fine. F of b e of x minus e of 0 1 f dash e raised to power t for t lies between this quantity. G dash is my 1. So that means this is true by using the Cauchy mean value theorem. So that means yes, this is my correct statement. So only S3 is the wrong, only right option is my D is the correct. Okay, look at this one. Which of the following is the largest possible value of this quantity? What come in your mind when you think about this quantity? I can return this quantity also in terms of this. Fine. I can multiply by 1 by root 2 and divide by 1 by root 2. I can change by pi by 4. So this number will be less than of. Clear? So how I can make them root 2 is a pi by 4. Also, if I choose the function is my cos x. Fine. Then what is the derivative is? Minus sin x. I need the derivative fb minus fa. This is my less than equal to 1. Fine. So that means because I need the largest value. So what is the maximum value of sin x? The maximum value of the sin x is 1 at the point pi by 2. So that means the function f changes maximally is pi by 2 at pi by 2. Now, since I compute as a pi by 4, so I can choose any number. Say x is my pi by 4, y is any other number, 3 pi by 4. Then what is my x minus y? X minus y is pi by 2. So you can see I already obtained the max values occurring at pi by 2. So the delta will be my pi by 2 is the right answer of this problem. Okay, let g is the continuous function of period p. F of x plus p is my f of x. You can choose any example of the periodic function, say sin x, fine, or you can substitute this. So x p is my period 2 pi, and this is my x, this is sine of t. If you integrate them, it is my minus of cos t x plus 2 pi 2x. So it's a cos of 2 pi is my cos of x, minus minus plus is my 0. So that means g is my 0. Every 0 function is a continuous. We said not continuous, not differentiable, cross. It's a constant function, fine, continuous, fine. Fine. This is the first method. Second method is if you want to solve it in simple manner. How you can remove this integration? I can differentiate this with respect to x. Then it's a g dash x. How you can differentiate this? I can take the upper limit at this point, x plus p, into derivative of this upper limit, minus substitute the lower limit and derivative of this lower limit. This is called as Leibniz rule of differentiation. That is x plus p minus f of x, and x plus p is my g. Fine, because both are same. So first derivative will be 0. That means the function is my constant. The function is constant. Every constant function is my continuous. A and B are my right answer. Okay, f is a continuous differentiable function. You can choose any number. Let's say f is my x, which is a continuous differentiable function. What is the f dash? 1. Substitute in this L. Limit x approaches infinity, x plus 1. Answer is infinity. But we need L is 0 to infinity. That means this value of the f I can never choose. Can you choose any other example? Always try to think a simple one. 1. Derivative is 0. What is the L? 1, which lies between 0 and 1. Now look at the option. F dash exists. Yes, because the limit is my unique. Fine. And is equal to 1. But f dash, what is the derivative of 0? It is not equal to 1. If f dash exists because the limit is my unique, then f is my 0, but f is my 1. So this option is also cancelled. If limit f dash exists, fine, then it is 0, correct. But this is one counter example, we can't correct them. F dash is 0, f dash exists, f is exist, then the limit is my 1. Yes, it is also fine. Now, look at that. How you can, because out of these two options, if I discard second option, then automatically the first one is the right answer. If I discard the first option, then second will be the right answer. So I can assume the first limit exists. First option is the correct option. Limit of the f dash exists and 0. Then my target is to check whether the second option is equal to L, that is 1 or true or not. If this is true, I can substitute this value at this point. L will be my 1. This is limit x approaches infinity f plus 0. That is, we obtained this. That means if I assume this is my correct statement, we have obtained the second one. Second case, if I assume second is my correct statement, I can substitute in this given equation. One is 1 plus limit of the f dash as x approaches infinity. That means f dash will be 0 as x approaches infinity. So what does it mean? If I assume this is my correct, I can obtain this result. If I obtain this is my correct, I can obtain this result. That means both are true if and only if. That means both are my correct answer of this problem. Now look at this another one. F and G are given to be. F is my increasing function. Your target is to prove G dash is my greater than 0. Second target is, your target is to prove this one. F dash is my decreasing function. This is your target. And the first target is prove this one. That's a very simple. I will give you this question as an exercise for you. You can solve this question and let me know your answer in the comment box with the proper explanation, so that I can try to understand whether you are able to understand this lecture easily or not, whether you watch this lecture in a full concentration manner or not. So let me know your answer in the comment box with a proper explanation. I will tell you which one is the right answer of this problem. So this is all about this today's lecture, and I hope this is my last lecture, because as I told you, I didn't get a good spot from you related to my videos. Best of luck student for your coming examinations. Happy learning always. Thank you very much.